So in this question here, find the area between y equals x cubed minus 1 and the x-axis from x equals negative 1 to positive 1. So let's say we go to Desmos here, and let's type in this graph so we can take a look at it. It's always a good idea to take a look at the graph. So y equals x to the power of 3 minus 1, looks like. So that's kind of what it looks like there, hey? Let's zoom in a bit. So here's negative 1 to positive 1, right? So I'm going to clip that as well. Does everything look appropriate there? Yeah, does that make sense? Let's get rid of this horrible drawing that I started. So just so we have an idea of what we're going to do with our... Okay, so it looks like that. And the graph itself, this is a boundary, this is a boundary. So we're looking for everything kind of between the graph here for all this.
Mr. Bright, please call
Right.
206. Mr. Bright.
So we're looking for this area. Okay, so this one, as I mentioned before, we might have to split this diagram up, but we actually don't have to. I'm going to bring this up a little closer, because we don't have to do that because the area is completely beneath the x-axis. You see that? This area. So we could take a look at what we learned in 10.1 here, and we could say that the area, right, under the curve is the capital F, that is the antiderivative of the function, evaluated at b minus the antiderivative evaluated at a. And of course, b is 1 and a is negative 1. See that? Now, if we do that, we're going to get a negative value because the boundary, this function, is below the x-axis. The x-axis is the upper. So if you wanted to, you could do this. If you could do that. And then we know that we're going to get a positive area. Yep. Okay, so the question we just had was, in order to do this, should you draw a graph first? The reason why you might want to draw a graph like I did, okay, is to see whether the entire area is either above or below. If the graph, like if it looked something like this, okay, and we had a section of the graph that was above the x-axis and then another section that was below, you would have to split this into two different questions. Right. Yeah. So it would be good to graph it. Yeah.
So I was just wondering.
Yeah.
We can have graphing calculator.
We'll talk about that later. Yeah. I mean, for the most part, I think you can have a graphing calculator. The thing is, you have to make sure you show all the calculus steps because there are ways on the graphing calculator that you can integrate and find derivatives, and like the calculator can do all this for you. So you just have to know that you would have to show all the proper calculus steps. Yeah. But having a graphing calculator to graph this to try and determine where this intersection is a wise idea for the most part. Yeah.
So we will be given it, or we'll have a graphing?
Yeah. We'll talk about that later. Okay. Whether you have a graphing calculator for this upcoming test or whatever, we'll talk about that later. Okay. So we good so far? All right. So we do not have the situation where we have to split it into parts. It's all underneath the axis. That's why we switched around the boundaries there. And we're going to get a positive answer if we do this. So the area function then, or if we want to find the antiderivative, right? Okay. What is the antiderivative here? Do you remember how to do that? How to take the antiderivative? We add 1, so that's going to be x to the 4. And then what do I do? 1 over 3 or 4?
4.
Yeah, 1 over 4. Good. So add 1 to the exponent and then multiply by 1 over that new exponent. Okay, and then we have a minus 1. So what does that translate into as an antiderivative? Minus x. Very good. Okay, so everyone's good with that? Simple taking the antiderivative. Now we evaluate at a. So a is negative 1. So it looks like this. So 1/4 to negative 1 to the power of 4 minus 1. And then we subtract. So I'm going to write it separately down here. Subtract 1/4 positive 1. Okay, and we evaluate that. We have 1/4 plus 1, and then we have minus 1/4 minus 1. Okay. So 1/4 are gone. +1 minus a -1 looks like 2. You get that for an answer? 2 units squared. Yeah? Okay. So there's that working out there. Again, the only thing you have to be careful with when you look at this graph and when you look at the boundaries here, just make sure if the graph is completely underneath the x-axis, then we're good to go, and you can switch these around if you want to get make sure you have a positive value. If you don't switch them around, that's fine. You're going to get a -2 then, and you'd have to realize that, yeah, if you have an area that's a negative, that's an issue. The only problem is you just take away that negative to make it a positive value. All right. So does that clear up your question for number 5? Any other questions there? Yeah?
Actually, I just have a question.